Hi, this is Pavel with a C# exercise from the book Visual C# 2012 How to Program. This one's from chapter 12 and this is exercise 10. We are going to be doing some shape hierarchy, so that itself will tell you that this is going to have a lot to do with object orientation, inheritance, abstract classes and so forth. So what we are going to be doing is to implement the shape hierarchy. There's a figure in the book which I don't have because it's in the book and I'm not going to go into some copyright infringement possible, so I'm not gonna show you that, but basically there's a figure that shows the shape hierarchy and there's two extra ones which we the triangle and tetrahedron that we are to omit. So anyway, it's gonna be easy to follow even without the image. So each two-dimensional shape should contain a read-only abstract property area to calculate the area of the two-dimensional shape. Each three-dimensional shape should have read-only abstract properties area and volume that calculates the surface area and volume, respectively, of the three-dimensional shape. And we are to create an app that uses the array of shape references to objects of each concrete class in the hierarchy. In other words, we will create objects and we will put them all in one array of shapes, regardless of whether it is two-dimensional shape or three-dimensional shape. They'll be all together. We will display a text description of the object to which each array element refers, and also in the loop that processes all the shape in the array, we will determine whether each shape is a two-dimensional shape or a three-dimensional shape, because if it is a shape that is two-dimensional, then we will display its area, and if it's three-dimensional, then we will display both the area and the volume. Alright, so two-dimensional shapes, I'll follow the book when it comes to what shapes we are going to be creating. So it's going to be a circle, it's going to be cube, it's going to be a sphere, square, and that's all. And we will also create abstract classes called shape. That's gonna be a superclass, and also three-dimensional shape and two-dimensional shape classes, which gonna be abstract classes. And for example, square will inherit from two-dimensional shape because it is two-dimensional shape, and a cube is a three-dimensional shape, so it will inherit from three-dimensional shape. All right, so let's get starting. So I'm going to start creating the classes. First thing, I'm going to create a class called shape, and this is going to be an abstract class. It's going to be a superclass, and we can do the constructor shape, and it will accept a size from which we will calculate, the what are we calculating? The volume and area, right? So we need to provide some measurements to begin with. So we will provide a size. All right. So and we will do a public property called side, which we will be using to get and set the size itself. So we can come back to the constructor and assign to our property whatever is being passed to the constructor. Now we are not going to be checking whether it's a valid value, or if it's a number and so forth. We will, because this is not going to really have any user input. This is all gonna be hard-coded. This is for a test demonstration only. So now we will do public abstract area, because both three-dimensional and two-dimensional shapes have area, and it's only private. We only get the area. We won't be able to set it because it's calculated. We will provide the side or the size of the side, and then we will calculate the area. So that's how we are going to get the area, not manually set it. And finally, our trusty, except this one is gonna be abstract, string to string. Alright, so that's our shape. I don't think we need anything else. So now we can go and do the three-dimensional and two-dimensional shapes. So I'll start with the two-dimensional shape. Two-dimensional shape. That's our class. And that too will be abstract. And just like since the shape, the superclass, requires the size of the shape, we need to pass it to it through a constructor. So we will create a constructor for the two-dimensional shape that will accept the side. I'll just call it A for short, but we will pass it back to our base. All right, and that's the constructor. I mean, we are not really gonna be doing anything within the constructor itself. So all right, what else do we need over here? So, well, we need the area. We need to override that, and it's gonna be still abstract because the actual calculations will be performed in the concrete classes. So abstract, and it returns double area and get, just like we did before, except we will this will all be calculated when we create the actual shapes or the objects for them. Now, as you can see, we have a squiggly here. Let me get that. Object does not contain constructor that takes one argument. And that's because we forgot, or I forgot, to inherit from shape over here. This is our abstract class that inherits from shape because we are using all the methods from it, and this one will hold the two-dimensional shapes only. Okay, so now I can do the toString method, public override string to string, except this one is not abstract. This one will actually display what shape this actually is. It's a two-dimensional shape, so I can return a string and format it, and it will simply say, now the final output will say something like square is a two-dimensional shape. All right, so we can do something like that here. So there will be a square, but square will hold its own name in its own class. It will return the word square. So over here we can simply do is a two-dimensional shape. So what is going to happen? The final output will say square, which is going to be in a toString method of the square class, and then combine it with this one. So together it will say square is a two-dimensional shape, for example, or circle is a two-dimensional shape from the class circle. Okay, so that's our two-dimensional shape. Our three-dimensional shape, let's create that one, and it's gonna be almost the same. Three-dimensional shape. The difference there is that this one will have a volume, not just the area but also volume. So let's not forget to inherit from shape, and also to make it abstract. And let's create a constructor. So our public three-dimensional shape, again we pass in the size of the shape, and we passing it back to our base class, or to the class called shape. So and actually we don't need anything in the constructor, but we need to create it in order to pass the value, because we expect to be supplied a value of the side of the shape. So we will do some overriding of the area. Abstract, so we will override the area. Again, it's just gonna be It's just gonna be a get. There's no set, this is just a read only. And public abstract double, and this one will be volume. Now, obviously the two-dimensional shapes do not have volume, but we calculate in volume only for three-dimensional shapes, and that too will be read only, so we only get. And public override string to string, and just like before, I'll just copy it. It will return what shape it is, so it will simply say three-dimensional shape. Alright, so that is our three-dimensional shape and a shape and our two-dimensional shape. So now we can start creating them. So let's start with the I don't know, square. So square will be our shape, the first one, and this inherits from two-dimensional shape. So consequently it also inherits from shape, because two-dimensional shape inherits from shape, so square as well inherits from shape. It inherits from all the classes that the you know, in the chain. And so let's of course get the constructor down. We're expecting a size, just like before. We'll pass it to our base, and just an empty constructor, we don't need anything there. So now we can calculate the area for the square. So we'll override the area, and this time we will implement it. So we will implement, it's only get, remember that we're not setting it, so we will simply return the calculation, so or the result of the calculation, and the area of a square is the side to the power of 2. That's alright, so the side is basically the A, that's what we are passing. We are getting it from the base class, which is in our case it's the two-dimensional two-dimensional shape, but that doesn't have that, but the class shape has that. It has the side, it has the property side. But since we are inheriting from two-dimensional shape, which inherits from shape, we have access to that because it's a public property, so we can and it holds the side that we are providing to the constructor. So if I pass 2 as my side, it will hold the value of 2 in the property side. So when I come over here, it will simply return 2 to the power of 2. It will return 4. Okay, so that's our square. Actually, let's do the public override string to string. And this one will return string formatted into, and it will simply say what shape this is, and it says it's a square. Plus, and this is where it combines the toString of the base class of the two-dimensional shape. So now it says two-dimensional shape as well. Base.toString. So we will combine these toString methods into one. It will say square is a two-dimensional shape. Alright, so that's our square. Let's do a three-dimensional shape now, so we can set that up too. And I'll do a sphere. And sphere, since this is a three-dimensional shape, it will inherit from three-dimensional shape. And we will create a constructor, sphere. And oh, I misspelled that, sorry. Sphere. Let's try again. Sphere, there you go. And just like before, we expect the size of it and passing it down to our base class. No nothing else needs to be done in the constructor. So this is a three-dimensional shape, so this will have area and volume. So let's do the area first. It's gonna be a double area, and in it returns, just like we did before, it will return the result of a calculation directly. We don't have to, create another variable to hold the value of the result. We can simply return the actual calculation or the result of it. Return, and this is the formula for the area of a sphere, times 4 times math. I believe it was to the power of 2, right? Math dot power, and we will do the base side again, the side to the power of 2. So what is it expecting? Oh, to close the bracket. So it's pi times 4 times base to the power of 2, or basically the base to the power of 2 multiplied by pi and then multiplied by 4. That's the area of a sphere. I found it on Google, so go ahead, Google it yourself. And public override double volume. Since this is a three-dimensional shape, we have a volume, and we will return, and it's the formula is going to be something like this: 4 times math.pi times math.power, again the base, the side, but this one is to the power of 3. Okay, so there. Again, I googled it, so I just kind of implemented it into the code. So you get the calculation first. So it's 4 times pi times base to the power of 3. That's the volume of a sphere. And finally, let's do the toString. So public override string toString. And just like we did over here, we will return a string with the base as well, and this one will say sphere. So basically it will say sphere, and then it goes to three-dimensional shape because that's its base class, is three-dimensional shape. Alright, so that's our sphere. Alright, let's create another one. Let's create cube. This one will be faster because I'll just copy paste everything that I just did, and so our cube, just like before, it's a three-dimensional shape, so inherits from three-dimensional shape class. And over here I'll just change it to cube, and obviously the formulas will be different. And the formula is 6 times or multiplied by the base to the power of 2, that's the area, and volume is just the base to the power of 3. Alright, and over here in the toString method we are calling it cube because it's a cube, so cube is a three-dimensional shape. So that's our cube, and let's do which one is next? Circle. And circle, it's a two-dimensional shape, so I'll just copy paste everything from our square that we did before. Let's not forget to inherit from two-dimensional shape. The constructor is of course circle. It expects one argument just like before, and the area is calculated. Let me see. It's the math.pi multiplied by base by the side, and in the toString method it's a circle. Alright, so we have a circle, we have a cube, we have a square, and we have a sphere. So let's go to our program and implement it. So let's create the array of shapes. So shape array, I'll just call it shape, equals new shape, and I will create 4 elements in it, one for each, one circle, one cube, one sphere, and one square. So that's our array of shapes, and I will just paste it. So shape 0 will have we'll have an object of square, and remember we are passing the size, and let's just make the size, I don't know, 5. That's gonna be the size of the square. Let me just copy paste that. So the next shape will be circle, the next shape will be, let's say, cube, and the final shape will be sphere, and they all can have the same size, 5. Alright, so that's our array. We populated the array with the objects, and now we can do for each loop we can loop through shape. I'll just call it element in our array, which is called shape. And it doesn't take that for some reason. Oh, because doesn't take it because I'm outside of the main method. Sorry about that. There you go. So we are looping through the shape objects in our shape array. And now remember, we have to figure out whether the object is 2-dimensional or 3-dimensional, because we are displaying different information. 3-dimensional, we are also displaying the volume, not just the area. Okay, so we can do something like, if the element is 2-dimensional shape, then we will output the console.write line, and you can just do element. So basically it will say, it will go and combine those two string methods. Alright, remember those, let's say if it's a square, the first one, it will come over here and it will say square, and then it will come to the 2-dimensional. Yeah, we'll just do that, 2-dimensional shape, and it will say is 2-dimensional shape. Alright, so that's one line, and then we will display the calculations or the result of them. So it will say, except this time I will format it a little, format, and it will say, the area is, and it's a number, so I'll just format it as a number, and then we will enter a new line for the next shape after that. So and the area is the element, and we have a method or the property area. There you go. So over here it will output the shape is a 2-dimensional array, and over here it will output the area is, and it will return the result of the calculation. So that is if this is a 2-dimensional array. Else, which means that it is a 3-dimensional array, and then we can simply output the volume as well. Now before we do, we need to there's one thing we need to remember. The volume and the area are only present in the three-dimensional array. That's why we are separating them. That's why we are finding out if it is a two-dimensional array shape or if it's a three-dimensional shape. So we can go and do console.writeLine just like we did before, and we will simply output the element. So it will say whatever the shape is, for example cube, because that's a three-dimensional array, a three-dimensional shape. Cube is a three-dimensional shape. That's the first line. Now we can do and I'll format it as well again like before. Format, and it will say the area is and it's gonna be the element not element dot area. And let's display the volume, string dot format, and it will say the volume is, and it's a number, and it's the element dot volume. Oh, we don't have, okay, good. Anyway, three-dimensional shape has the volume, which is an abstract, so I have to actually cast the because the shape itself, the superclass, does not have the volume. We don't need it there because we are a two-dimensional array. Two-dimensional shape does not have a volume, so we did not put it into our superclass. We put it into our another abstract class one level above it, which is the three-dimensional shape. However, remember we are having a array of shapes. We don't have an array of three-dimensional shapes or arrays of squares or anything like that. We have just shapes, which is this one. So when I come over here now, the volume is not available to our shape. I have to cast it into a three-dimensional shape before I can use it. Alright, so I'll go about here where it says else, and I will perform a cast. So I will call it 3D shape, and it equals, and this is another cast. Remember, the first one we have element is three-dimensional, and we cast it that way, but this time we are doing it three-dimensional shape, just like that. We are casting the element into the three-dimensional shape. So what does it say? Cannot implicitly convert. Oh, it's because this is something else. I just clicked it and it wasn't really the class. There you go. So 3D shape is now a three-dimensional shape. It's not a shape anymore. It's a three-dimensional shape. So over here we check if it is a 2D shape or if it is a three-dimensional shape, and if it is, we will simply perform the cast. We could cast the two-dimensional shape as well, but there's no need because we have all the methods and all the calculations directly into our built into our shape superclass, which is the area. That's all we need for the two-dimensional shapes. But since three-dimensional shapes uses also volume, we need to perform the cast because the shape class does not have the volume property or the method. Three-dimensional shape class does. So that's why we have to cast it or convert it to a three-dimensional shape. Okay, so so over here, instead of element, it's gonna be the 3D shape, and now you can see now we have the volume right here. Alright, so that will display that, and actually this I will pass to the end, and at the end of the program I will just pause the screen, so I will do console.read key. Alright, well, let's run it, let's see what we get. If it builds, of course it doesn't. The namespace or end of file definition. I have probably too many brackets right there. It displayed the sphere as the first one, but the object reference not set to an instance of an object. So let me see what's going on there. And over here, when I see what I did, I have everything into 0 for some reason. You should have told me. Why don't you yell at me? You were probably yelling at the screen like, Pablo, what the hell are you doing? Yeah. Oh, sorry, I didn't hear you. Anyway, here's the result. So it says square is a two-dimensional shape, the area is 25, circle is a two-dimensional shape, the area is 1571, and now it says three-dimensional shape, cube, and then the area and the volume, and then the sphere is three-dimensional shape, and the area and the volume. Let me get the trusty Google and I'll see if the calculations were performed correctly. So the first area of square, I probably shouldn't have to do this one, right? But hey, we pass in 5. What am I doing? Come on. Wow. Ah, jeez. Hell, here I am. Okay, so 5. Alright, obviously it's 25. That was, you know. But hey, so what was the next one we have? Circle. So let's do circle. And we passed 5. So it says 7854. So obviously that is not correct. I'll look at it. And three-dimensional shape was a cube. Area of cube. We are passing 5, so it's 150. That's correct. And then the volume. Volume of cube. Again, we are passing 5, so it's 125. And that's correct. And finally, the sphere. So the volume of sphere, and if you pass 5, 523.6, that's wrong. And alright, let's try the area of sphere, 314.16. So that's correct. So I have to fix the circle and the volume of the sphere. And the sphere, I have the formula wrong. After we do all the multiplication, I just check the formula again. I just typed it wrong. We have to divide. Oops, I'm still running the code. We have to divide it by 3. So over here, all this will now be divided by 3. So that's for the sphere. Let's see the circle. What's wrong with that one? So it's that should be actually correct. Alright, let me try the sphere. The volume of sphere should be 523.6. So let's run that, and now it is 523.6. But I think the square was wrong, right? I mean the area of circle. And it says 78.54. Then I have 15.71. And I think that it is because I didn't do the power of 2. I believe. I have pi times the radius. Yeah, this should be to the power of 2. There you go. Sorry, it's getting a little longer now because of that, but I wanted to leave it there just so you see that it's not always very smooth sail. So that's the power of 2 for a circle. So let's try it again. And now we have it 7854. So now we have all the values correct. Okay, so I guess I'm not a math whiz, obviously, but I did figure out where the problem was. That's something. Alright, so that was the inheritance and the abstract classes. I hope this was helpful. But before I go, I want to do a little refactoring because we are repeating ourselves. This is the same for both, so like this and this as well. The only difference is the volume. So what we can do, we can take this out, put it right on the top before any if statement, and then only check if this is not two-dimensional, but if this is a three-dimensional shape. And if it is, then we will do the casting and we will output the volume. Alright, so because like again, this is gonna display for both shapes, whether it's two-dimensional or three-dimensional. And if it is a three-dimensional on top, on the bottom of this, it will also output the volume, or that's the plan. So let's see if that's gonna work. And it does. You can see it does. The spacing's a little wrong. It says there's extra space over there. So I can just take it out of here and put it at the beginning. So that way, and take this one out. So now it should be formatted okay. Well, alright, so no, it's not. Jeez. This one should be not at the beginning, this one still should be at the end, because that's the whole block, that's the end of the block. Alright, so now it is. So now we have it, the properly formatted output, we have the correct calculations, we have the correct display of whether it's two-dimensional or three-dimensional shape, and we reduced a few lines of code as well. Okay, so like I said, I hope this was helpful. If you have any questions, you can leave the comments. If you like the video, please like it. I'm sorry it took a little longer with all the mistakes, but that's a learning experience, I guess. And I'll see you in the next video. Take care.